Section 10.2, graph y equals ax squared plus bx plus c. So the characteristics of the graph is that it's a parabola, and it opens up if a is greater than 0, and it opens down if a is less than 0. It's going to be narrower than the graph of x squared if the absolute value of a is greater than 1. And it's going to be wider if the absolute value of a is less than 1. The axis of symmetry is going to be at x equals negative b over 2a. And the vertex will have the x-coordinate of negative b over 2a. The y-intercept is going to be c, so the point 0, c is on the parabola. So we're going to find the axis of symmetry and the vertex of this example, here. So we have y equals 3x squared plus 12x minus 8. So we're going to identify a, b, and c first. So a is the coefficient of x squared, which is 3. B is the coefficient of x, which is 12. And c is the constant term, which is negative 8. So we're going to find the axis of symmetry. Our axis of symmetry is x equals negative b over 2a. So now we're going to go ahead and substitute in. So x equals negative, b is 12. 2 times a is 3. Negative 12 over 6, which is negative 2. So our axis of symmetry is x equals negative 2. Then we're going to find the vertex. So we know the x-coordinate of the vertex is negative 2. We're going to plug that into our function to find out what y is when x is negative 2. So every time I see x, I'm going to go ahead and put in negative 2. And then I'm going to see what I get. Negative 2 squared is 4. 12 times negative 2 is negative 24. 3 times 4 is 12. 12 minus 24 is negative 12. Negative 12 minus 8 is negative 20. So my vertex is at negative 2, negative 20. Okay, so in the next example, I'm going to graph y equals 2x squared minus 8x plus 7. So I'm going to identify my axis of symmetry and my vertex. So let's see, a is 2, b is negative 8, and c is positive 7. So my axis of symmetry is x equals negative b over 2a. So it's going to be negative 8 over 2 times 2. The negative becomes a positive, so this is 8 over 4, which is 2. So my axis of symmetry is x equals 2. For my vertex, this is my x-coordinate. I'm going to plug it in to find my y-coordinate. Two squared is 4. 4 times 2 is 8. Minus 16 plus 7. 8 minus 16 is negative 8. Negative 8 plus 7 is negative 1. So my vertex is 2, negative 1. So now I'm going to start graphing this. I'm going to go ahead and plot my vertex, 2, negative 1. I'm going to go ahead and draw my axis of symmetry in. I know that since this is a positive 2, I know that it's going to open up. So then I'm going to pick values on one side or the other, and then I'm going to use my axis of symmetry to find another point. So I'm going to go ahead and find out when x is 1 and when x is 0. So when x is 1, I'm going to have 2 times 1 squared minus 8 times 1 plus 7. So I have 2 minus 8, which is negative 6, plus 7 is positive 1. So when x is 1, y is 1. Likewise, when I go 1 to the right of the vertex, I'm also going to be up at 1 using my axis of symmetry. When I put in 0, I'm going to get my y-intercept, which is c, which is 7. So at 0, I'm going to be up at 7. Which is going to be like up here. And then when I'm to the right of the vertex, I'm also going to be up there. So then I'm just going to go ahead and draw that in. And you have your graph. So then minimum and maximum values. For a function y equals ax squared plus bx plus c, the y-coordinate of the vertex is the minimum value of the function if a is greater than 0. Because if a is greater than 0, it opens up, and we're going to have a minimum value right here. Make sure you remember that the minimum value is the y-coordinate. It occurs at the x value, but it is the y value. And then if a is less than 0 and our parabola opens down, we're going to have a maximum at the y-coordinate of the vertex. So to find a minimum or maximum value, what you want to first do is determine if you have a minimum or a maximum, and then you're going to find the vertex to find out what the minimum or maximum value actually is. So here we have f of x equals 2x squared minus 16x plus 4. So we want to determine if there's a minimum or a maximum. So since this coefficient of x squared, my a value, is positive, it's going to open up, which means I'm going to have a minimum value. To find my minimum value, I'm going to first find my x-coordinate of the vertex. And that's x equals negative b over 2a. Well, a equals 2 and b is negative 16. So that's going to be negative 16 over 2 times 2. This becomes a positive 16 over 4. 16 divided by 4 is 4. I'm going to plug 4 back into my original function. So I'm going to do f of 4 to figure out what my minimum value is. So 2 times 4 squared minus 16 times 4 plus 4. 4 squared is 16. 16 times 4 is 64. 2 times 16 is 32. 32 minus 64 is negative 32. And negative 32 plus 4 is negative 28. So my minimum value is negative 28. It occurs at x equals 4. Okay, and then our last example is finding a minimum value of a function. The cables between two telephone poles can be modeled by the equation y equals 0.0024 x squared minus 0.1x plus 24, where x and y are measured in feet. To the nearest foot, what is the height of the cable above the ground at its lowest point? So we want to find our minimum value. So first we're going to find our x-coordinate of our vertex. So negative b over 2a, negative 0.1 over 0.0024 times 2. The negative becomes positive. And then we're going to put that back in for x. I'm just going to go ahead and leave it like this. And then when you go ahead and calculate that, you get about 23 feet for your minimum value.